so now I want to show you another way that we present the data, because the rest of the data that I show you I'm going to present in a tree kind of a format. So what I just showed you is averages, right, over all the 16 isomorphic series of questions, and you see trends, but you don't necessarily know which students are going from correct to staying correct versus students who are maybe incorrect at the beginning and achieving knowledge by the end of your series of questions. So the other way we
Can I ask a question?
Yeah.
Because I'm now becoming obsessed with statistics because I don't understand them whatsoever.
Well, I don't.
I don't
very
understand.
Well
I don't understand them at all. But I'm impressed by how tiny the error bars are.
Yeah.
And I'm confused as to, you give a difficult question, so you get the same question being run multiple. So all the difficult questions are varying by that little. They're all coming in at around.
Yes,
18%.
but remember, we selected these, we labeled these difficult after the fact.
So you started them because they were less than 20% or something.
Yeah, there were 4 questions on which the performance, the correct, less than 20% of the students got the answer correct.
So here's where I'm just confused. This is not meant as a, I'm just totally befuddled.
No problem.
And my view would be if there were 4 questions, and if the responses differed from like 5% correct to 15% to 20, those error bars should be bigger, right?
They were actually, there were none that were that low.
Okay, so they're all about the same.
Truly, there were 4 questions that were very similar in terms of the percent correct.
And those errors are surely standard error of the mean, not standard deviation.
They are standard error of the mean.
So
I have to write that down.
In there, right?
It's a lot of students. It's 350 students. 350 students. So yeah, it's the standard error of the mean, not the standard deviation. Thank you.
Okay, good. Thank you.
So if it's a class of 100, that's an order of magnitude difference.
That's an order of magnitude reduction in the error bar when you do that.
Okay, now everything makes sense to me.
Great. I love it when that
Are you
happens.
making fun of me or?
No. If I was going to make fun of you, you wouldn't be asking a question.
You know it, Steve. Okay, so let me show you this way of demonstrating or of showing the same data. Okay, so all the students, here they are. They are all taking, we're taking data points from all of them, and we can follow each student because it's a quicker question series, and so we have ways of identifying the students. So we can say, okay, on the first question, we can divide all the students into 2 groups. And over these 16 questions, about 52% of the time, 52% of the students got the question correct. So then we can continue to follow that line of students. So the students who got question 1 correct, overall, they went on to then vote 92% of the time correctly on the second version of Q1, so after discussion. And then from that population of students, 90% of those students went on to answer the second question correctly. So if you start off with the correct answer, you have a very high chance of getting the second question correct, which is really not surprising. I mean, this Q1 here follows a short lecture of some sort or a short presentation, something, where information is transmitted. So these students either knew it before the lecture or they learned it from the lecture, and now they're able to apply it and they keep applying it. People who, on the other arm, got question 1 incorrect.
Jenny?
Yeah.
Even before you show the other arm, I think it's interesting that out of the 8% who got it wrong, when they looked at the second question, it's not true that almost all of them missed it.
Exactly.
It's still like
so
5,
the neighbors
6
messed them up.
students.
Or they
convinced them.
or they didn't really get it. They guessed on the first question.
Yeah.
And so when they were then talking with their neighbors, they're like, oh, I didn't really know, I just pricked A, you know, because students will definitely do that, right? These are not affecting their grades, these clicker questions, it's just for participation. So that would be my interpretation of these people, is they didn't really know what to start with. Okay. They're confused by the discussion. It doesn't help them. They don't have a very good chance of getting it correct. On the other side, if they get the first question incorrect, they still have a chance of getting the after discussion question correct, but it's not a terrifically high percentage of those students who go on to correct their understanding. However, if they do correct their understanding here during the discussion, they have a relatively high % chance of getting the second question correct. It is not as high as this, it's significantly different, but it is certainly higher than this percentage over here. People who are incorrect, they just have a hard time getting to the correct answer for Q2. So students who are correcting their initial responses are benefiting from the peer discussion and are able to go on and apply that knowledge to the next question.
So one could argue they're benefiting. I think this is more evidence for conceptual knowledge generation during discussion, because they're developing it to the extent that they could use it later.
Yes, yes, and that's why this second question is so important, because it doesn't just show you what happens after discussion, which again, you don't know whether students are just, well, I'll just try B this time. Here, they're actually being asked to apply it a second time, and if they're getting it right, they probably really do understand it.
Have you tried putting an isomorphic question on the final exam for the course to see if there's long-term?
Yes, and I will tell you about that.
Okay.
But not yet. Okay, so,
I have a quick question.
Sure.
I don't know if you said this. How long did you wait before you asked that second question? Was that immediately following?
it's pretty much immediately following. So the first question is asked, the students are given a minute or two to answer the question, then they're given a minute or two to discuss the answer, and then they get the second question.
Okay.
So only minutes have passed.
So in terms of classroom management, you've asked a question, they've answered it twice now,
Yep.
and you still haven't given them any feedback
Yep.
on correct
Right,
answer, and
right.
you just throw another question. Is
Right.
there any issue in the classroom about discomfort of students? Because my students, there's perceptible discomfort if the
Right.
correctness is not addressed.
So you have to do it this way, and this wasn't my class, this was actually Tintin Sue's class, but this is, I saw her slides, and this is how she did it. She said, now I'm going to ask you a series of questions, and I'm not going to tell you the answer until the end. So first I'm going to ask you the question,
Okay.
you're going to vote,
That's what
you're going to
we do.
discuss, vote again,
They know-
and then I'm going to
they
give you the
know
second
that-
question, then I'm going to tell you the answers to all the questions, and you'll be happy little campers before you go on to the next topic. So you have to tell them the answer is coming. Yeah, you will be.
That's good.
You have to let them know, and so we're very careful about that. And when our protocol deviates from that and we're doing something different, then we also still tell them, okay, I'm going to explain it, or I'm going to do this, and then you're going to get this. We always tell them what's coming. That way there isn't the uncertainty of, oh, what's going on? When am I going to get the answer? Yeah. Okay, so this was all done in MCD 2150, the genetics class for majors, in fall 2008. And we wanted to ask whether the pattern that we saw here, which was pretty successful, we were convinced that there was some construction of knowledge going on, doesn't hold true for other classes. And what are the impacts on retention? So this addresses some of the other questions that have already come up about how, is there any longer term effect of these clicker questions? So that's number 3. And then number 2 is we also wanted to vary a little bit how we dealt with the questions in the classroom. So rather than not telling them the answer before they get the second question, what would happen if then, after the students talked to each other, you then had sort of a class-wide discussion of the answer before they get the second question? So adding what we call an instructor explanation, which I'd like to say often is not the instructor just saying, this is the answer, but instead is the instructor saying, what did you guys think about that question? You know, why would somebody vote for C, etc. So an instructor-led discussion of the correct answer, then followed by a second question. How will that change the dynamic of how students answer? So these questions we addressed in my class, a non-majors class in genetics, which has fewer students in it. So the numbers aren't quite as robust as they were for the previous work that I just described. So, so the basic protocol is quite similar, except for the addition of the instructor explanation. So students answer a clicker question, they talk to their neighbors, instructor discusses the answer with the whole class, then they're given another question, and after that the instructor also discusses the answer. And then finally, we use this protocol to then go on and ask a retention question later. So it's all the same as what I've told you about up to here with the addition of the instructor explanation. And then several days later, usually the next class period, we ask them another isomorphic question. So this is now the 3rd question on this topic. And we call that our retention question.